Hey everyone, and welcome back to The Explainer. Today we're looking at something literally so massive in scale, it's fundamentally rewiring how our entire world operates. We're going to pull back the curtain on the foundational architecture of the future, what we're calling the digital to physical pipeline. We're taking a really close look at NVIDIA's AI master plan, and let me tell you, what they are building right now goes far, far beyond just graphics cards or those simple text generators we've all played with. So let's just cut to the chase and ask the big question that's kind of on everyone's mind. What exactly comes after generative AI? Chatbots and image generators are super fascinating, right? They've completely captured the public's imagination. But when you look at the unprecedented, literally planet-scale processing power that NVIDIA is deploying right now, you realize pretty quickly that chatbots are just the tip of the iceberg. So what are they actually building with all of this unbelievable compute? To really grasp the scale here, just anchor yourself with this one massive number, 81%. Today, NVIDIA technologies power a staggering 81% of the world's top 500 fastest supercomputers. They are absolutely the undeniable engine of this new era. But an engine needs a vehicle, right? And it needs a purpose. To unpack that purpose, we're going to use a stack framework today to build our understanding from the ground up. Here's our agenda. We'll start with the AI computing powerhouse, then building the AI factory, followed by simulating reality with Omniverse. From there, we'll hit the physical AI frontier, scaling autonomous vehicles, and wrap up with global impact and future. So we're going from the raw base layer all the way up to real robots on our streets. Let's jump into section 1, the AI computing powerhouse, the foundation of the future. Because before you get intelligent machines, you have to build the foundational infrastructure. And NVIDIA is rapidly arming the globe with that exact infrastructure. Just look at Europe. They've recently unveiled a record 35 new NVIDIA AI supercomputers to equip millions of researchers. And then there's the Jupiter exascale system. Now, this isn't just for doing math super fast. Jupiter is actually Europe's first exascale supercomputer specifically dedicated to advancing climate, brain, and 6G research. This is the serious heavy lifting required for the next generation of artificial intelligence. Which naturally brings us to section 2, building the AI factory, or AI as a 5-layer cake. We're really framing this shift as a brand new industrial revolution. Think about it this way. For decades, the traditional data center's job was pretty simple. Store data, host some apps. It was basically a giant digital filing cabinet. But an AI factory is an entirely different beast. It's a full-stack infrastructure where you don't just store things, you process raw data tokens into a brand new commodity. You are literally manufacturing intelligence. It's wild to think about. So how is this factory actually organized? NVIDIA uses this brilliant metaphor, saying AI is like a 5-layer cake. See, they aren't just a chip company anymore. They provide the whole stack. You've got the compute hardware sitting at the base, then your system software. Next up are the AI libraries like CUDA-X, which really unlock that scientific discovery. On top of that, enterprise platforms like Omniverse. And finally, at the very top, the AI models and agents themselves, things like Nematron and Cosmos. You really need all 5 of these layers working in total harmony to manufacture intelligence efficiently. Moving right along to section 3, simulating reality with Omniverse, the virtual proving ground. Because before a single physical factory is ever constructed, it has to be rigorously tested in a virtual world. To really get this, we have to understand the term digital twin. A digital twin is a large-scale, physically based virtual simulation of a real-world product, process, or system. And the key here is that it's not just a pretty 3D model. It actually obeys the real laws of physics and chemistry. If you drop a wrench in a digital twin of a factory, it falls at exactly 9.8 meters per second squared. And you can see industry giants absolutely jumping on this to radically compress their development timelines. TSMC, for instance, uses it to advance super complex semiconductor design. Dassault Systems is literally embedding the actual laws of physics and engineering into their world models. And Siemens? They're building highly secure, autonomous AI engineers to compress weeks of tedious simulation work down to just a few hours. They are testing the future before it even happens. It's a real game changer. All right, let's zoom out to the real world for section 4, the physical AI frontier. Once you perfect that intelligence in the virtual space, it's time to bring it into ours. We've talked a lot about generative AI, sure, but this right here is physical AI. These are AI models actually capable of reasoning, running a simulation, and then generating a physical action out in the real world. This is the absolutely crucial bridge between digital smarts and physical movement. And the centralized brain powering this entire new frontier, that's the Cosmos 3 Omni model. It elegantly combines reasoning, simulation, and action generation all into a single open frontier foundation model. Cosmos 3 acts as the core intelligence for robots, autonomous vehicles, you name it. Instead of hard-coding a robot to pick up a cup, Cosmos 3 lets the robot independently reason about the cup, simulate the actual physics of grabbing it, and then smoothly execute the action itself. But look, a brain needs a body, right? And it certainly needs safety protocols. That's where the NVIDIA robotics ecosystem comes in, giving developers the exact tools they need to build and deploy physical AI at a massive scale. You have Isaac, which is their open platform for building the robots. You've got Jetson, the embedded hardware that lives right inside the machine to process AI on the edge. Then there's Halos. And this is huge. It's the industry's first full-stack physical AI safety system for humanoids and industrial bots. Add in massive global partners like Dassault and LG Group, and you have the foundation to build next-gen AI factories everywhere. Now, take that intelligent robot, put it on 4 wheels, and drop it onto public roads. That's Section 5, Scaling Autonomous Vehicles. We're basically watching the rapid evolution of mobility happen in real time. It kicks off with model development, using open reasoning models like Alpamayo 2 Super. That is a massive 32 billion parameter model built explicitly for autonomy. From there, the software is loaded into in-vehicle computing through the Drive Hyperion architecture, which is a fully Level 4 ready platform. And finally, we hit real-world deployment. Major automators, think BYD, Mercedes-Benz, Hyundai, they are actively integrating these full-stack systems to put advanced software-defined robotaxis on our actual streets. So, as we zoom out even further, we realize this isn't just about cool factories or cars. We're talking macroeconomic and planetary implications. Section 6. Global impact and the future. Take Earth 2, for example. This is, hands down, the ultimate digital twin. It's the first fully open, production-ready weather AI stack in the world. It makes planetary-scale weather AI and climate modeling totally accessible. When you combine the raw computing power of an AI factory with the simulation capabilities of Omniverse, you can literally model the Earth. You can predict, prepare for, and potentially even mitigate major extreme weather events before they hit. And make no mistake, entire nations are taking notice. We're seeing this massive, undeniable trend toward what's called sovereign AI. Countries are waking up to the fact that intelligence is a critical national resource, and they're buying into NVIDIA's infrastructure to secure their own technological independence. You've got Naver in Korea building JSX-based AI factories. SK Telecom is expanding AI cloud capacity nationwide. The UK is aggressively ramping up its sovereign compute, and like we mentioned earlier, Europe has just unveiled 35 new AI supercomputers. So, as we wrap up this explainer, I want you to consider how NVIDIA themselves view this exact moment. They are calling this history's largest infrastructure build-out. And honestly, that isn't just marketing hype. We are quite literally watching the bedrock of modern industry being poured right in front of our eyes. The AI factory is absolutely the new power plant of the 21st century. Which leaves us with one final, very important question for you to chew on. The pipeline is laid. As digital intelligence inevitably crosses over into physical reality, walking in our factories, driving on our streets, modeling our actual weather, what will your AI factory build? Thanks so much for watching, and as always, stay curious.